Hello there, and welcome to 2-1, Solving One-Step Equations. We're in Unit 2 now. Our learning target is that I can solve one-step equations. And for our title and everything, we know we got to put our name in that top right-hand corner and today's date. And now, we know we've seen equations before, but sometimes I think we forget what the goal of solving equations is. So just to kind of refresh our memories, the goal when solving equations is to find the value of a variable by isolating isolating. I kind of grabbed an O in there instead of a NG. Isolating the variable on one side of the equation of an equation. Now, we all know that isolating just means we're going to get it alone. So if we're going to isolate the variable, so the whole part of that just means we're going to get variable by itself. Or get the variable alone by performing opposite operations. Now we know from our order of operations is add, subtract, multiply, divide. So when we say we do the opposite operation, if it's being added, we're going to subtract. And if it's being multiplied, we're going to divide. So we're going to do the opposite operation to isolate our variables. Now one of the first ways we're going to look at it is to transpose. So that's our next part we're going to look at. So to transpose means we're going to take a term being added or subtracted. Oh, it scooted on me. So being added or subtracted to the variable. To the other side. My T kind of looks like an F there. Let's kind of clean that up a little bit. To the other side of, I'm just going to put an equal sign. So to the other side of the equal sign with appropriate sign change. Oh, I didn't give myself enough room. I'm going to go below sign change. And that's okay, because I needed to come down here anyways to kind of show what I mean. So, for example, if it's addition, you change the sign to subtraction on the other side of the equal sign, and vice versa. If it's being subtracted, we're going to change it to addition. Here we go. And now look at our steps. Alright, step 1, locate variable and what's happening to it. There we go. Is it being added? Is it being subtracted? Alright, step 2. Let's do green. There we go. So, step 2 is to transpose term being added or subtracted. Oh, it scooted on us again. Oh, it went all the way over there. Term being added or subtracted And then down here, this little part A, you just kind of make it a star because they're just going to put remember to change the sign. And lastly, we're going to check our solution. Make sure our answer we have is actually the correct answer. Alright, so let's see some examples of solving for a variable by transposing. So example 1, we are asked to solve m minus 48 equals 29 and check our solution. Alright, so first things first, we see our variable. He's on the left side of the equal sign. We look at what's happening to him. He's subtracting 48. So now that we know what's happening to him, we're going to transpose what's being added or subtracted. So our 48 is being subtracted. And by transpose, we're going to take it to the other side. So my m's going to stay here on the left side. My equal sign just drops down. My 29 just drops down. And my negative 48, or my minus 48, comes over here to become a plus 48. And now 29 plus 48 gives us 77. So m equals 77. Now, for this one, we're going to do a formal check where we actually make sure it's the correct answer by substituting in the value of m for 77 in our original equation. So the original equation is m minus 48 equals 29. M, we know, is 77. So 77 minus 48 equals 29. You can punch that into the calculator real quick, or you can subtract it in your head, and we get 29 equals 29. And that's true. That's nice and balanced. So that does check. You kind of I always think about it like being like that balancing board. As long as it's the same on each side of the equations, we're good. Nice and balanced. Okay. Now, let's see another one. Get into the habit of transposing here. So example 2. We have 142 plus d equals 97. Once again, we're asked to solve and check our solution. So first things first, what's happening to our variable? He's here on the left side. He's being added to 142. Alright, now to solve for d, to isolate him, we're going to transpose our 142 to the right side. So my d is going to stay on the left, my equal sign drops down, my 97 drops down, and now my positive 142 comes over here to become a minus 142. So positive 142 becomes a negative 142, and now 97 minus 142 gives us a negative 45. So d equals a negative 45. Once again, we're going to do a true check where we take our original equation, 142 plus d equals 97. And we're going to perform our check by replacing d, it's not a very pretty d, there we go, d with negative 45. So 142 plus a negative 45 equals 97. If some of you are like, oh, she wrote two signs there, I know, I don't like double signs either. So if you have plus and negative, because they're different, it's actually just minus. So it's actually like 142 minus 45. Punch that into the calculator, do it in your head, you get 97. And 97 does indeed equal 97. So that checks. Alright, now for this next one, we're going to practice using Desmos. So have that handy as we look at example 3. So we have g plus 3/4 equals a negative 1/8. Okay, so the first thing we're going to do is locate our variable. There he is, he's on the left side. What's happening to him? He's adding 3/4. So to get rid of it, we're going to transpose our 3/4, and since he's a plus 3/4, we take him over here, and he'll become a minus. So we drop down our g, drop down our equal sign, drop down our negative 1/8, and now say plus 3/4 becomes a minus 3/4, and Desmos is going to come to play where we have those fractions. We're going to say g equals, and now negative 1/8 minus 3/4. So use our fraction button here, negative 1 over 8 hit the over button to get outside of it, minus, then fraction button, 3 over 4. And if you look at it, it shoots me out this decimal here. But because we're using fractions, we want our answers fractions, so I'm going to hit this convert to fraction button. And it's going to be a negative 7/8. So negative 7/8. And this one doesn't call for a formal check, but if you have Desmos handy, you can always just plug it in up here for this g and say negative 7/8 plus 3/4 and see what we get. So negative 7/8. Now we can hit plus. Try this again. See if I can hit the right buttons. So negative 7/8 plus 3/4. Oh, didn't hit the over button, did I? Backspace, over button. Plus 3/4. And we want to convert it to a fraction. It gives us a negative 1/8. Is that what it originally equaled? Negative 1/8? It was. So it's all good. Alright, for our next part, we're going to switch over now to solving equations by multiplying and dividing. So step 1 for us is still the same. We're still going to locate the variable and see what's happening to him. Okay, once we have our variable and we know what's happening to him, oh, I lost my happening, there we go. Step 2 for this one is to do the opposite operation to both sides of the equation. I'm just going to put of equal sign because we know the equal sign means it's an equation. And just to kind of, once again, you don't have to write AB if you don't want to. You can do stars, you can do bullets, you can whatever you want to. But just to refresh our memory, we know if we're going to be multiplying, the opposite of multiply is to divide. And same way here. If we are dividing, we know the opposite of it is to multiply. Last little bit is to, as always, check, make sure our solution's all good. Check solution. Oh, that looks like a W. That's a U. There we go. Check solution. Alright, let's see some of these examples now. So example 4. We're given 4 t, if you notice back a little curly key on my t, equals negative 32. So we look at our equation, we have our variable here, he's on this left side, he's side by side with the 4, so if 4 and t are side by side, that means they're actually being multiplied. Well, not a decimal, they're being multiplied, there we go. So the opposite deal of multiplication is to divide, so we're going to divide both sides by using a fraction bar. Please show a fraction bar instead of the divide sign, so fraction bars show our division, then divide both sides by 4. So 4's cancel out on this side, because if you multiply by 4 and you divide by 4, it's opposite operation, so they cancel. And then t is going to equal negative 32 divided by 4 is negative 8. There we go. And now for this one, we'll do a true check to just make sure we're all good. So we got 4 times t equals negative 32. We know that t is negative 8, so 4 times, I'm going to use parentheses for my multiplication there, times negative 8 equals negative 32. Negative 4 times negative 8 is negative 32. And negative 32 does indeed equal negative 32, so we're set. Alright, example 5. We have negative 25 equals negative 5x. Once again, we locate our variable. This time he's on the right side. We see what's happening to him. He's being multiplied to negative 5 there. So the opposite of multiplying by negative 5 is to divide both sides by negative 5. Negative 25 divided by negative 5 is positive 5 equals negative 5 divided by negative 5 cancels out. X is all we're left with, and we're set. And we're not going to do a formal check with this one, but if you needed to, you could just say 5 times 5 is negative 25, so that does check. That all works out. Alright, so we wrote our m over 7 equals 4. Now we look at what's happening to our variable m. That fraction bar we know means he's being divided by 7. So the opposite of being divided by 7 is to multiply. So I have to show my multiplication by parentheses again. So parentheses, multiply this side by 7, this side by 7. When you multiply by 7 and you divide by 7, they cancel and leave us with just m equals 7 times 4 is going to give us 28. There we go. And if you want to double check it, just put in 28 up here. So 28 over 7 is 4. So that checks. Alright, example 8. We have 25 equals z over negative 4. Once again, we look at what side our variable is on. Z is over here on the right side this time. What's happening to our z? We know that fraction bar tells us to divide. So since he's being divided by negative 4, we're going to multiply both sides by negative 4. Negative 4 times 25 is a negative 100 equals, now negative 4 multiplying and then dividing by negative 4 cancels out and leaves us with just z. And we're good. Z's by himself. We can check our solution saying negative 100 divided by negative 4 gives us 25. So we're all set. Now in true fashion, I give us one that's in fraction form. So 3/4 b equals 15. Now there's different ways to think through these, but one thing I like to do is just say we have b, here's on the left side. If they're side by side, 3/4 and b, that means they're being multiplied. So we're going to actually divide both sides by 3/4. The opposite operation there. So 3/4 cancel out. And now we're going to pull up our Desmos real quick, and we're going to put in this side right here. Oh, sorry. Pull this back up. We're going to put in this right here. So we're going to put in 15 divided by 3/4. So 15 divided by fraction, 3/4. So Desmos already kind of defaults their division symbol to be the fraction bar. And then we put a fraction on the bottom of it. And we get 20, which is right. So we'll get b equals 20. Another way to do that is to go back up here and just double check it and do 3/4 times 20 and see if that gives you 15. You can always go back to Desmos and just put in there 3/4 and then over button times 20. And that gave us 15, and that's what it originally equaled, 15. So that works. So we're all good. And then one last one, example 10. We have negative 8 equals 2/5 t. Once again, we look at what's happening to our variable. There's on the right side this time, he's side by side with 2/5. So since they're side by side, they're being multiplied. So now we're going to divide both sides by 2/5. Divide this side by 2/5. 2/5 cancel out. And remember, we're going to put the division sign in there for Desmos. So Desmos, we're going to put in there negative 8. Wrong button. I apologize. Let's hit the back button. There we go. Divided by, now the fraction button. And my fraction was 2/5. So forgot to click my button there. 2/5. Enter. And we're good. It gives us negative 20 as well. So, negative 20 equals t. And we're all set. And that finishes up with our examples for one-step equations.